right, so in 2.5 we talked about how to now solve polynomials that have imaginary roots in conjunction with real roots. And then how if you're given the roots to get to the polynomial. So that's like number 1. It says find a third degree polynomial function with real coefficients that have 3 and 2i as zeros. What is a third degree polynomial function? It's x to the third. So if you had messed this up, let's say, and you result in something that says x to the second or x to the fourth, hopefully that's something that checks you right there, that this is supposed to be x to the third. Okay, and that's because you're missing one of the roots, right? But you know it to be what? Negative 2i. So if there's a complex root like 2i, then the conjugate is also a root. So then I would write this out as a product of linear factors, x minus 3, x minus 2i, and x plus 2i. And then I would FOIL out and I would start with the i's because those are conjugates, right? If I multiply them out, I'm going to cancel out the I. All right, so x squared plus 2ix minus 2ix minus 4i squared. This I squared becomes a negative 1, and I'd get x squared plus 4 because these two cancel out. Bring down the x minus 3, and then multiply that out. So x to the third plus 4x minus 3x squared minus 12. And then I would rewrite it in decreasing degree order and set it equal to f of x. So anytime it's asking you for a function, you want to make sure you set it equal to f of x. Raise your hand if you got that one right. Okay, good. Any questions before we move on? Okay, number 2 says, what are the zeros of the function? So the first thing I would do is see if this is factorable. Is it? No. Then I would say, okay, if it's squared, I could use the quadratic. It's not squared, okay? Or I can't use the even root property, which means the only other option I have is to figure out the possibles and see which one works, okay? So 150 is a big number. That means it's going to be a lot of multiples. So I get 1 and 150. I get 2 and 75. I get 3 and 50. Does 4 go into it? No. 5. I'm going to keep going down. 5 and 30. 6 go into it? Yep. 6 and 25. 7 doesn't go into it. No, 7 ends in a 0, right? Except for 70. 8. Does 8 go into it? Eight, right? Divided by 8. This would be 1. This would be 70. 8 doesn't go into it. How about 9? Do any multiples of 9 end in a 0 besides 90? Right? No. 10. 10 and 15. 11. No. 12. 13. 14. And we've gone back up to 15, right? So here's my multiples of 150. And the first number is just a 1, which means all of those will go over 1. So I'd get plus and minus 1, 2, 3, 5, 6, 10, 15, 25, 30, 50, 75, and 150. And then I'm going to use synthetic division to see which of those work. So I get 1. I don't have an x squared term, so 1, 0, negative 11, and 150 are my coefficients. God bless you. God bless you. And I'd start with 1. Doesn't do it. So then I go to negative 1. I go to 2. Because that last number is so big, you might want to jump and see if you can find something that's in the middle that might be an upper bound or a lower bound. Remember, if it's an upper bound, so if it's positive and the bottom row is all positive or 0, then I know that's as high as it can go. And if it was negative, I know it's as low as it can go if it alternates positive and negative. So what's one you found? -6. So I do 1, -6, -6, 36, 15, nope, 25, and then -150. All right, so I've just reduced it a degree. This is now quadratic. Okay, is that factorable? Are there factors of 25 that sum to -6? No, which means quadratic formula. A equals 1, B equals -6, C equals positive 25. And I get negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Six plus and minus the square root of 36 minus 100 over 2, which is 6 plus and minus negative 64 over 2. The square root of negative 64 is what? 8i over 2, and I get 3 plus and minus 4i. All right, so now the question is, what are the zeros of the function? What's your answer? 3 plus 4i. 3 minus 4i. And -6. All three of those are zeros of your function, okay? And you would have to include them all. If this wanted it, and didn't say it, but if it wanted it in linear factor format, I would get x minus 3 plus 4i, x minus 3 minus 4i, and x plus 6. So this would be x minus 3 minus 4i, x minus 3 plus 4i, and x plus 6. So if it asks for it as a product of linear factors, that's what this is, linear factors. These are your zeros or your roots. And if I had multiplied out the linear factors, you should get back your original question. All right, so the question comes up, what happens if there's not a 1 in front of my x to the third? So let's say it's a 2, okay? When I'm finding my possibles, I would put all of the factors of the last over 1, which I did here, and then I'd go back and put all those factors over 2. So I'd get 1 over 2, 2 over 2, 3 over 2, 5 over 2, 6 over 2, 10 over 2, 15 over 2, 25 over 2, 30 over 2, 50 over 2, and 75 and 150 over 2. And then I would go through and reduce those as much as I can. So this is going to stay. It's going to get added to my possible. But this becomes a 1, and I already have a 1. This is 3 over 2. That would get added to my possible bank. 5 over 2 is going to get added to the possible bank. This becomes 3, and I already have it. This is 5. I already have it. 15 over 2 would also get added. 25 over 2 would get added. 30 over 2 would become 15, and I already have it. 50 over 2 would become 25, and I already have it. 75 over 2 would get added. And 150 over 2 is 75, and I already have it. So my possibles are going to include all the ones I had at the beginning. 1, 2, 3, 5, 6, 10, 15, 25, 30, 50, 75, 150, and also 1 half, 3 halves, 5 halves, 15 halves, 25 halves, 75 halves. positive and negative version of each one. I'm not going to try to kill you on the quiz. I don't want you spending that long on these, so you're probably not going to have that many possible roots, but they won't necessarily all be whole numbers. And they're not always going to be like, you know, there's not going to be 4 possible roots. There might be more than that. So just be prepared to do your trial and error. And when you're doing your synthetic division on your quiz, don't erase the work that you've done, because if you, let's say the root is -1, and you missed it, and you keep working and you can't find it, and you have erased your work from -1, I can't give you partial credit for it. So make sure you don't erase your work, okay? Obviously, when you're doing it on the homework, it's different. You can just like erase the terms, but on your quiz, you definitely don't want to. On your quiz on Thursday. So your quiz on Thursday is 2.4 and 2.5. No graphing calculators, so we'll save those for the test, okay? 2.4 covers all the stuff with complex numbers, adding, subtracting, multiplying, finding the conjugates, and dividing the complex numbers. So when I asked first class, everybody felt pretty confident about the adding, the subtracting, the multiplying. Do you echo that? Yeah, okay. Finding the conjugate, so if I said 2 plus 3i, you'd tell me it was 2 minus 3i. Okay, and really you just need that to do the dividing of the complex numbers. So if I were to look at the example that's there, I can't leave that I in the bottom because it's the same thing as leaving a square root in the bottom. So I would rationalize by multiplying both the top and the bottom of the conjugate, which is? Good, 4 plus 5i. So in the numerator, I would distribute 3 times 4 is 12. 3 times 5a is positive 15i. 4i plus times 4 is a positive 16i. And then 4i and positive 5i is positive 20i squared. So I'd get 12 plus 31i. And then this becomes a -1, so that becomes a -20. So I get -8 plus 31i. And that's my numerator. The denominator, I could either FOIL out 16 positive 20i, negative 20i, negative 25i squared, which becomes positive 25, or use your shortcut, which is a squared plus b squared. So the a is the 4, the b is the 5. You take the number without the I, so it would be 5 squared, and you put a plus between them. 16 plus 25, which is 41. And then I want to split it, and if I can simplify it, I would. Neither of those can be simplified, so you can leave it the way it is. Questions on that one? Just be careful. I'm going to pull out the colored pencils. It tends to help with stuff like this, especially when we get to the ones where we're multiplying, you know, like a trinomial times a trinomial. It's a lot easier to do it color-coded. Also from 2.4 was solving quadratics using the quadratic formula, so that x equals -b plus and minus the square root of b squared minus 4ac over 2a. And for these, sometimes they're positive underneath that root, sometimes they're negative underneath the root. If it's negative, you would need to bring the I out to the outside and then simplify the root. So no fraction should go unsimplified and no square root should go unsimplified, ever. Any questions, specific questions on 2.4? Okay, and then 2.5 was finding the possible roots and then dividing synthetically to find your x squared or your x to the third that's factorable, and then finding the remaining roots by using the quadratic or factoring. And writing the roots as linear factors. So this is your x plus or minus a number, x times x plus or minus a number. So both examples 3 and 4 kind of lead into that type of a problem. We used the graphing calculator to verify on example 4. You won't have the graphing calculator. So just make sure that you know how to find it without it. And then finding a function given the roots, which is like we did in the warm-up. I give you the roots, you give me the function. And then the last examples in the notes was 6a and 6b, where you were given a function. You were given a root, like a imaginary root. You had to multiply it by its conjugate and then divide using that on the outside. So there are practice problems from 2.4 and 2.5. There's a quiz review, okay, that's non-graded because the answers are on there. The 2.4 is actually on, the answers are on at the back of the page with the review. And then the 2.5 is a separate document, but that's worked out with the answers on it as well, okay? It's non-graded, so if you're seniors, you have 2 days to look through it, okay? If you're juniors and you want to focus on the PSAT prep tonight, get a good night's sleep, that's fine. Just make sure you do it tomorrow. If you know you're going to be brain fried after the PSAT tomorrow, then maybe flip-flop that. Okay, and do a little bit of reviewing for the quiz tonight so that you're not doing all that tomorrow. So both 2.4 and 2.5 reviews are on Canvas. Questions on either of those? Anybody need an example worked out other than what we've done so far? Okay, so then the last thing we'll talk about is PSAT, okay? So PSAT is in your homeroom, which you haven't been to today, so so far this year, right? So make sure you know where your homeroom is. I'm sure if it's in a lab, I know for sure that it is relocated. They'll probably send that out in the morning, so just watch your announcements. So if you were in like the science lab or a computer lab or anything like that for homeroom, you're going to be relocated. Just look for it. Make sure you bring your calculators with you, okay? It would stink to take that SAT without a calculator, especially since you have graphing calculators now. They're a lot more helpful. There's one portion of the SAT math section that does not allow the calculator, but the other ones do, so take advantage of it. Get a good night's sleep. Get something to eat because it's a long test with no snack breaks, okay? So you want to make sure that you go. You're not allowed to have your phone in the room with you. You're not allowed to have a smartwatch. If you have an Apple Watch, leave it at home. You're not allowed to have any of that stuff in the room with you. No food, nothing.
You have to wear a uniform sweater?
Yep. And I would bring a sweater because you don't know where you're going to be. So I would wear your regular shirt and bring a sweater because you don't know where you're going to be.
What time does it end?
It's usually 12-ish, but it literally, all of them have to get packed up, accounted for. Literally, like every single one has to get counted before they can dismiss the rooms. So that's an ish. At the very end, like once your room is complete, you can probably have a snack. So if you wanted to bring something with you, if you have a locker, maybe put in your locker or something like that, that would be a good idea. There is no penalty for guessing. So if you get to the end, you have 5 minutes left and you have 15 blanks, fill them in with your favorite letter, okay? Because there's no penalty for guessing. You get the same thing if you get it wrong as you do if you get it blank. So you might as well at least try for it, right? You got 1 in 5, 1 in 4 chance. Just be careful. Make sure you read directions. So on the iTunes U course, there's a bunch of